And now let's solve one more question. Prove that tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8 is equal to pi upon 4. And in this question, first we shall simplify the left hand side and then prove that the left hand side is equal to pi upon 4 and which is equal to right hand side. And for that, first we shall add tan inverse 1 upon 5 to tan inverse 1 upon 7. And the result of this sum will be added to the sum of tan inverse 1 upon 3 and tan inverse 1 upon 8. And for adding tan inverse 1 upon 5 to tan inverse 1 upon 7, we shall use the trigonometric property as per which tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy. So in place of tan inverse 1 upon 5 plus tan inverse 1 upon 7, we can write tan inverse 1 upon 5 plus 1 upon 7 divided by 1 minus 1 upon 5 into 1 upon 7. Similarly, in place of tan inverse 1 upon 3 plus tan inverse 1 upon 8, we can also write tan inverse 1 upon 3 plus 1 upon 8 divided by 1 minus 1 upon 3 into 1 upon 8. And further simplifying, left hand side becomes tan inverse 7 plus 5 upon 35 divided by 35 minus 1 upon 35 plus tan inverse 8 plus 3 upon 24 divided by 24 minus 1 upon 24, and which is equal to tan inverse 12 upon 34 plus tan inverse 11 upon 23. And now again applying the property for sum of tan inverse x and tan inverse y, where x is equal to 12 upon 34 and y is equal to 11 upon 23, and the product of 12 upon 34 into 11 upon 23 is also less than 1. So adding these two terms, the left hand side becomes tan inverse 6 upon 17 plus 11 upon 23 divided by 1 minus 6 upon 17 into 11 upon 23, and which further simplifies to tan inverse 325 upon 325, and which is equal to tan inverse 1. And tan inverse 1 means the angle for which tangent is equal to 1. And in the interval minus half pi to half pi, that angle is pi upon 4. So that means left hand side is equal to pi upon 4, and which is equal to right hand side. So that means tan inverse 1 upon 5 plus tan inverse 1 upon 7 plus tan inverse 1 upon 3 plus tan inverse 1 upon 8 is equal to pi upon 4. So now let's solve some question based upon the properties of inverse trigonometric function. And our first question is, prove that tan inverse 1 upon 9 plus tan inverse 1 upon 3 is equal to tan inverse 2 upon 3. And here left hand side is tan inverse 1 upon 9 plus tan inverse 1 upon 3. And tan inverse x plus tan inverse y is equal to tan inverse x plus y upon 1 minus xy, where xy is less than 1. And here x is equal to 1 upon 9 and y is equal to 1 upon 3. So x into y is equal to 1 upon 27, which is less than 1. So now let's apply this property. So now left hand side becomes tan inverse 1 upon 9 plus 1 upon 3 divided by 1 minus 1 upon 9 into 1 upon 3, and which is equal to tan inverse 1 plus 3 upon 9 divided by 9 minus 3 upon 9, and that becomes tan inverse 4 upon 6, and that finally becomes tan inverse 2 upon 3, and which is equal to right hand side. So that means tan inverse 1 upon 9 plus tan inverse 1 upon 3 is equal to tan inverse 2 upon 3. Now let's solve one more question. Prove that 4 tan inverse 1 upon 5 minus tan inverse 1 upon 70 plus tan inverse 1 upon 99 is equal to pi upon 4. Now here left hand side is equal to 4 tan inverse 1 upon 5 minus tan inverse 1 upon 70 plus tan inverse 1 upon 99. Now 4 tan inverse 1 upon 5 can also be written as 2 into 2 tan inverse 1 upon 5. And we have already learned that 2 tan inverse x is equal to tan inverse 2x upon 1 minus x square, where modulus of x is less than 1 and 1 upon 5 is less than 1. So here we can use this property. So now the left hand side becomes 2 into tan inverse 2 into 1 upon 5 divided by 1 minus 1 upon 5 whole square, and minus tan inverse 1 upon 70 plus tan inverse 1 upon 99. And further simplifying, tan inverse 2 into 1 upon 5 upon 1 minus 1 upon 5 whole square becomes tan inverse 2 upon 5 divided by 1 minus 1 upon 25, which is equal to tan inverse 2 upon 5 divided by 24 upon 25, and which finally becomes tan inverse 5 upon 12. So the left hand side becomes 2 tan inverse 5 upon 12 minus tan inverse 1 upon 70 plus tan inverse 1 upon 99, and which can be also written as 2 tan inverse 5 upon 12 minus tan inverse 1 upon 70 minus tan inverse 1 upon 99. And now to simplify 2 tan inverse 5 upon 12, we can again use the formula for 2 tan inverse x, and tan inverse 1 upon 70 minus tan inverse 1 upon 99 can be simplified by using the property by which tan inverse x minus tan inverse y is equal to tan inverse x minus y divided by 1 plus xy. So now the left hand side becomes tan inverse 2 into 5 upon 12 divided by 1 minus 5 upon 12 whole squared minus tan inverse 1 upon 70 minus 1 upon 99 divided by 1 plus 1 upon 70 into 1 upon 99. After further simplification, tan inverse 2 into 5 upon 12 upon 1 minus 5 upon 12 whole squared is equal to tan inverse 5 upon 6 divided by 144 minus 25 upon 144, and which is equal to tan inverse 5 upon 6 divided by 119 divided by 144, and which is equal to tan inverse 120 upon 119. Similarly, tan inverse 1 upon 70 minus 1 upon 99 divided by 1 plus 70 into 1 upon 99 is equal to tan inverse 99 minus 70 upon 70 into 99 divided by 70 into 99 plus 1 upon 70 into 99, and which is equal to tan inverse 29 upon 6931. And also tan inverse 29 upon 6931 is equal to tan inverse 1 upon 239. And now here again we can use the trigonometric property as per which tan inverse x minus tan inverse y is equal to tan inverse x minus y upon tan inverse 1 upon 1 plus xy. So the left hand side finally becomes tan inverse 120 upon 119 minus 1 upon 239 divided by 1 plus 120 upon 119 into 1 upon 239, and if you simplify it, you'll find this is finally equal to tan inverse 1, and tan inverse 1 is the angle the tangent of which is equal to 1, and in the interval minus half pi to half pi, that angle is pi upon 4. So left hand side finally becomes pi upon 4, and which is equal to right hand side, and that's what we wanted to prove. So 4 tan inverse 1 upon 5 minus tan inverse 1 upon 70 plus tan inverse 1 upon 99 is equal to pi upon 4.